Hello everyone. Today I am going to solve problem 4 of homework set 7. So let's go through the question. So the question says CO2 in water has a Henry's law of constant of 1.25 into 10 to the power 6 mmHg, and we need to calculate the mole fraction of CO2 which will lead to bubbling up. Basically, like what's the total amount of CO2 that got dissolved in the water with a total vapor pressure of CO2 which is equal to 1 atmosphere. So it's given Henry's law of constant. You can already assume that we need to use Henry's law or Henry's formula to solve this mole fraction, or to find the mole fraction, the amount. But let's know, why do we need to use Henry's law, or is it like lazy to use Henry's law? So Henry's law can be only used if there is a gas that gets dissolved in liquid. So if gas is getting dissolved in liquid, then we can use Henry's law. The second thing is, if the pressure is very less, if pressure is very less, then we can use Henry's law as well. So here the pressure is 1 atmosphere, so you can roughly assume, yes, we can use the Henry's law. So okay, so our Henry's law constant is given in mmHg, but the given pressure is 1 atmosphere, so we need to convert 1 atmosphere to mmHg. So 1 atmosphere is basically equal to 760 mmHg. Now we know the formula for Henry's law. It's P which is the pressure or the vapor pressure. P, vapor pressure, is equal to Henry's law constant into mole fraction. So we can calculate mole fraction, basically P over KH. So P is given 760 mmHg, and more KH it's given 1.25 into 10 to the power 6 mmHg, which will, if you calculate these two, mmHg cancel, put it in a calculator, we will roughly get the answer 6.08 into 10 to the power minus 4. So the mole fraction of CO2 that got dissolved to create a vapor pressure of 1 atmosphere is roughly equal to 6.08 into 10 to the power minus 4. Thank you very much for your attention. Let me know if you have any questions.